All right, welcome to our continued discussion about inverse trig functions. And in this video, we're going to focus our attention on using the inverse cosine function. So if you missed the first video on the inverse sine function, that went a little more in depth, and this video is building upon that. So if you're not quite following, you may want to go back to that one. Okay, so to start this discussion, we really need to remember what the graph of y equals the cosine of x looks like. And we've got that hill and valley kind of graph like y equals sine of x, except it's translated a little bit. So the first thing to think about would be, as this is graphed, does this function have an inverse that is also a function? And so we would want to say, in this case, no again, because it fails the horizontal line test. Anywhere that you drew a horizontal line, we would see that it fails. So we handle this by restricting the domain, just like we did with y is equal to sine of x. But if we restricted it like we did for y equals sine of x, from negative pi over 2 to pi over 2, it would still fail the horizontal line test. So the interval that we're going to choose is going to be a little bit different. We are going to choose the interval from 0 to pi. Okay, and so as we look at what that interval looks like, we've got a section of the graph that passes the horizontal line test, and then it allows us to define the function y is equal to cosine inverse of x. So for that restricted window for our input from 0 to pi, so let's go ahead and fill in this table. Y is equal to the cosine of x. So what is the cosine of 0? Cosine of 0 is 1. The cosine of pi over 6, that would be rad 3 over 2. The cosine of pi over 4 is rad 2 over 2. The cosine of pi over 3 is 1/2. The cosine of pi over 2 is 0. And then on into the second quadrant, the cosine of 2 pi over 3 would be negative 1/2. The cosine of 3 pi over 4 would be negative rad 2 over 2. And the cosine of 5 pi over 6, negative rad 3 over 2. And last, the cosine of pi would be negative 1. So if we plot these points on a coordinate plane, we get a partial picture of the y equals cosine function, but that is exactly what we want to restrict our domain of, so that we can then look at what does the graph of y equals the inverse cosine look like. Okay, so remember what we're going to do with that. We are going to take our outputs and make them our new inputs, right, for our inverse function. And then our outputs here will be what was our input in our original y is equal to cosine x function. So we're going to go ahead and fill in our table there with those values. And when we plot this on a coordinate plane, we end up with a curve that looks like this. And notice that it is all above the x-axis because our outputs are all above the x-axis. So similar as before, our function for our restricted domain of y equals cosine x is strictly decreasing, and our graph for our y is equal to the cosine inverse of x is also strictly decreasing, but we see that the curvature of the graph is a little bit different. The concavity is how we describe that is a little bit different. Okay, so then let's look at how do we define the inverse of the cosine function. And this is really similar to what we did with the sine function. The inverse cosine function uses the notation of either arc cosine of x or cosine inverse of x. and it is defined to be the inverse of the cosine function that has a restricted domain of 0 to pi. Okay, so we take that restricted cosine function and we turn it into our cosine inverse function. So what that implies is y is equal to cosine inverse of x. It means the same thing as x is equal to the cosine of y for that restricted domain, which also restricts your range, right? Because the restrictions of our y value on the cosine inverse are the same as the restrictions on the domain of our cosine function from 0 to pi. And then the restrictions on the x of our cosine inverse function will be the same as the restrictions on the range of our original y is equal to cosine of x function, right? Remember that varied from -1 to 1. So then how do we actually use that inverse cosine function? So we're going to be able to use our unit circle to evaluate some inverse cosines, and then we're going to use our technology to evaluate inverse cosines that are not on the unit circle. So we're going to start with things that are, though. Okay, so this is where we're going to evaluate the exact value of cosine inverse of things that you know from the unit circle, right? These values are values that you see in the coordinates on the unit circle. And remember that our restricted range for the cosine inverse function is 0 to pi. That's our restricted domain on the cosine function, so it's our restricted range on the cosine inverse function. And remember that 0 to pi is the top half of the unit circle. So we are going to be thinking about only angles that exist on the top of the unit circle. So we're focusing our attention on these values. So when I'm looking to evaluate the exact value of cosine inverse of rad 3 over 2, I am looking for an angle that has an x value of rad 3 over 2. Okay, so looking along this unit circle, find an angle that has a x value in the coordinate of rad 3 over 2. Okay, and you should find it here, right? And so you just pull the angle measure that goes with that, which is pi over 6. Okay, and then do the same thing for -1/2. We're looking for something along the unit circle on the top half there that has an x coordinate of -1/2. And you can find that right here. And then you just, again, pull the angle measure. Okay, so that's your thought process to evaluate things that are familiar from the unit circle. Now, a lot of things aren't, though, so we're going to go ahead and use some technology to evaluate some things that we are not used to seeing as x values on our unit circle. Notice all these things, these are unfamiliar to us. It's unfamiliar territory, so we're going to grab our technology and approximate here. So use your graphing calculator, your scientific calculator, whatever you happen to have handy. Your phone will even do this. So remember that cosine inverse will be found on your technology as the second function on your cosine. So you're just going to put second cosine and then 7 over 8. And you're going to make sure that your calculator is in radian mode, and we're going to go ahead and pull what comes out. We get an approximation of 0.5054. Well, what does that mean? That means 0.5054 radians. If I took the cosine of that angle, I would get 7/8. Okay, so it's always wise to check and make sure that when you write it the other direction, you get the same thing out. So cosine inverse of -0.0124, Well, we just, again, crunch this in our calculator. Second cosine, negative 0.0124, gives us a result of 1.5832 radians. Again, worth it to check. Cosine of 1.5832 radians should equal negative 0.0124. Does it? Check it in your technology and make sure. All right, try this next one. Find the cosine inverse of 17.2. Check that in your calculator and you should get error. Uh-oh. Okay, remember that the restrictions on the output of the cosine function are negative 1 to 1. So that means the restrictions on the input of the cosine inverse function are also negative 1 to 1. That 17.2 does not fall within that interval, so I cannot actually evaluate the cosine inverse of 17.2. All right, that wraps up this video. In our next video, we're going to talk about the inverse tangent function, and I'll see you then.